Now it's time for one of our favorite topics, data analytics. Since we're really running a little late, I wouldn't take much time, and I'll straight away introduce Mr. Varun Aggarwal, who's going to be taking this session on data analytics. Varun is the vice president at EXL Analytics and leads a team of 150 plus data scientists. He has over 14 years of experience in consulting in advanced analytics and has solved complex problems for Fortune 500 companies across the banking, telecom, and utility sectors. Over the years, he has authored research papers in the field of predictive modeling, presented at various international data analytics conferences, and also published papers on credit loss forecasting. Varun has led development of multiple analytics products and has bagged more than 5 prestigious awards at EXL for innovation and intellectual capital development. Thank you, Varun, for joining us today. It's an absolute pleasure to have you with us. Varun, once again, we've heard you once last year as well on one of our sessions, and it's so nice to see you again. Over to you,
Maya.
Varun.
Thank you, Maya, for a wonderful introduction, and thanks a lot, everyone, for giving me this opportunity to talk about data analytics today. First of all, happy Republic Day to all of you, and congratulations EduBridge Learning for conducting such a great event, which is going to cater to a lot of folks. So let me share my screen, and please let me know if I am you can see my screen or not.
Yes, Varun, we can.
Okay. All right. So the topic of discussion is how to become a data analyst without coding background. So first of all, let's ask a question: is coding background necessary to become a data analyst? So before going there, a simple question: what do we do when we get hungry? Right? We typically have two options: either we order or we cook ourselves. Right? So when we order, we have basically a shortcut. We just pick up a phone or use any app and order. But when we have to cook, again, there are two options: either we assemble all the ready-made ingredients, or we go with a do-it-yourself approach, where we get into the kitchen, try out every single thing, and try to make that food for ourselves. And so if we understand this analogy, we can apply it for insights as well. So when we're hungry for generating insights, what do we do? So again, we have multiple tracks here. So track one says that, okay, we can leverage our low or no coding platforms where there's not going to be any need for coding background or acquiring coding skills. It's easy to use, and you can still contribute to the analytics field. The track two would be where we leverage our existing functions and libraries. Here we can use open source tools or even the licensed tools that have inbuilt functions and libraries which we can easily call and analyze the data. Here the coding skill requirement would be of intermediate level. And if you look at the track three, where we can create our own algorithms, here the coding skill requirement will be a bit advanced. However, we don't need to worry about that. We can evolve during the process and learn these skills over time. Right, so before moving forward, let me also give you a couple of tips. So when we go with track one, we have to choose our toppings wisely, which essentially means that even when we're using the low or no coding algorithms or platforms, we should not be just doing everything without logical reasoning. So for example, let's say a very simple example of using Excel and inserting chart. So if we need to analyze a time series data, because we should not be looking at histogram, but the line chart. And that's a very basic example I'm quoting here, just to convey the message that we have to pick the statistical test or whatever analysis tools we need very wisely before getting into generating the results, because the results need to be meaningful so that you can take some business actions. If we go with track two, where we leverage existing functions and libraries, again, my advice would be to add your secret sauce, which essentially means that even after ensembling different things or using the functions and libraries, you will need to make sure that the solution is customized to the given problem statement, to your organizational data, to your business problem. Otherwise, it will be difficult to make some decisions that will be specific to the underlying problem statement. So you have to add some basically some uh, additional wrapper around it so that you can make that solution viable for your organization. If you go with do it yourself technique where you create your own algorithms, again you need to keep evolving those algorithms, or I would say you may even need to change your cuisine, which essentially means that you probably are solving today a problem for the banking vertical. You may want to solve something for insurance vertical or something else within banking. If you are solving problem for say marketing, tomorrow you may want to solve problem for operations. So if you want to become a successful data analyst, you have to keep challenging your skills and keep acquiring new skills every time. Now, one more point to keep in mind is the track 2 is a sweet spot. Those who do not have any coding background or do not understand coding well, and you don't need to worry. You can start with track 1, but eventually track 2 would be something which you should aim at and try to at least leverage the existing functions and libraries. And even if you have good coding background, most of the problems can be solved just by staying at track 2. I'm not discouraging you to go to track 3, but my suggestion would be to at least make yourself competent to use the existing algorithms that are available in the market. Let me discuss the next part, which is coding background sufficient to become data analyst? So we saw that coding is not necessary. You can still enter into the field of analytics without knowing coding. But answer to this one is absolutely no. So definitely coding alone is not going to help us. But before understanding this, we need to know what data analytics is all about. Now, if you want to define data analytics, you can simply create a definition and say that it's understanding patterns in data in a systematic way to make decisions. Now, each of these terms, understanding patterns, data, systematic way, and making decisions, these terms are very, very critical and important to understand what skills we need to become a data analyst. So now let's look at deeper look at it. Uh, so if you divide the entire process into 3 parts: processing data, understanding patterns, and making decisions. For processing data, we need primary skills as data extraction and data engineering. So data extraction is important because you need to read the data. The data may be huge in volume, it may be small. You need to have that ability to at least read the data and then start processing it. So data engineering would involve a lot more analysis on top of it, doing the right crosstabs, summarizing it, creating new features, and making it usable for the next step, which is understanding patterns through domain knowledge. Right? So here in understanding patterns, domain is, I would say, the most important part. Unless and until you understand the context, you won't be able to relate what kind of analysis you are getting. The second important part here is data visualization. If you're able to visualize the data well, you can also communicate your findings. Thirdly, statistical techniques are important. There are certain tests that are applicable to a certain set of problems, may not be applicable to all blindly. Hence, it is important to have some understanding of the applicable stats. I'm not saying that we need to be expert in statistics, we need to have a degree in statistics, but some understanding of statistical techniques would help you in the long run that can generate some meaningful insights for your business. To make decisions, the skills that we need are logical reasoning, because that's an important step where you need to accept or decline a given solution. You need to be result oriented. You have to think from business standpoint. You also have to think from implementation standpoint. And communication skills are going to play an important role here, because there will be a bunch of people in the organization who may not be able to understand how different statistical techniques work or how the data can be leveraged. So you have to communicate those findings properly so that you can get the necessary approvals to actually implement the solution. So these are primary skills. So domain knowledge, for example, I would say is critical for even processing data, but that's secondary. So if you have these skills in mind, you know that how to go about it. You do not have to just stick to coding. There are certain other things that we need to keep working on to become a successful data analyst. Just to quickly recap what we have covered so far, coding background is not necessary. I'm just repeating it so that we understand that we have learned something new today. It's definitely not necessary to become a data analyst. There are ample avenues where you can contribute to analytics field, like by just designing the solution, by processing the data, by creating those views which can be passed on to those who can code better. The other way is that we can learn coding. It should not be a rocket science for us. If we do not have the coding background, we should be open to at least leverage existing functions and libraries to actually compete with the fellow data analysts. The second part here is coding background is definitely not sufficient. What we have learned today is that there are some other building blocks that comprise domain knowledge and context. We have to bring the business sense into play, statistics and science, the algorithm, the technique, the approach behind that, logical reasoning through which you're going to design the solution, accept or decline the solution, and communication and alignment through which you're going to get the implementation plan and get the solution deployed. Now let's move to the next part of the session, how to get started. Now, if we want to get started in the field of analytics, we need to understand how analytics work, what kind of problems it solves. Right? So from business standpoint, there are certain decisions that are to be made. Examples could be business growth. So if not, say the business is not doing well, you have to expand. So then you have to apply analytics and see if there are ample opportunities to take a stab and grow it further. But apart from profitability that are going to impact your revenue and cost directly, there are other factors as well. For example, process efficiency. There are ways to save a lot of money just by making your processes more efficient, by removing the redundancy. The third important objective that we typically see is customer targeting, which essentially means that if when you are launching, let's say, a new product, which customer you should target. If you are even retaining the customers, which customers you should target first. So there is a need for also segment the population and prioritize them. The fourth important point or the business objective here is customer experience. And typically we see that there is a trade-off between profitability and experience at times. But customer should be the center of attraction for any business to run successfully. And hence we need to ensure that we keep customer above all other objectives. So here you will see that you will need to do some optimization whenever you need to make decisions on maximizing profitability and maximizing the customer experience. The fifth objective is loss mitigation, which basically caters to the bottom line of the business. Here we are not generating revenue or growing revenue, but the objective is to protect the organization from any impending penalties or regulation requirements, or let's say, for example, capturing fraud. If you can save fraud, you can save money. Instead of growing revenue, you are reducing cost, and hence you're increasing the profitability. So these are the kind of problems that are typically solved through analytics. But this is a perspective of, I would say, a business. If you think from the analyst standpoint, then let's look at the problems that we typically solve in analytics project. So there are 6 kind of problems. The first one is estimate a value. So a good example here could be, let's say you're working for an insurance company and your objective is to decide what premium should I charge to my customers. Here you're going to estimate the premium amount for every single customer that you have. So this is a problem of estimating a value. So here I would say the target variable is continuous in nature. Secondly, the second kind of problem is classification problem, where you need to predict a category. It could be a single category, it could be multiple category. An example could be a credit card issuer would want to see which transaction is going to be fraudulent, which is genuine. So to classify such transactions, you may need to build a statistical model that can give you probability of fraudulent for each transaction. The third kind of problem that we see here is identifying the segments. An example could be say, marketing division of a company that needs to decide how to target my customers so that I can get the maximum response. So here the objective is to divide the entire customer base into some homogeneous segments that are different from each other, but within each segment, the customers are similar. The fourth example is discovering the association. So example here could be you are working for, let's say, a e-commerce platform, and you need to make a recommendation engine where when you're selling an item, you need to also recommend the customers who bought this item should also try to buy other things, right? So the customers that have done that in the past may be able to influence you. So here the objective is not estimation, but finding the right association and creating a recommendation engine for your customers. The fifth example or the kind of problem statement is when you need to forecast a time series, right? Here an example could be when you're working for an operations segment of your uh, organization. Here, let's say for customer care, you need to decide what resources you need to allocate throughout the day. So basis the data, you can estimate what would be the expected call volume every hour, and accordingly you can do the stuffing. The sixth example is when you optimize allocations. Here we can take an example of a smartphone company that has a given budget, and they need to use the budget to maximize their return on investment on media channels. So they will take a decision whether I should go for a TV campaign, or whether I should do a digital campaign, whether I should send emails, or whether I should do out of home advertisement. So those kind of decisions are taken by optimizing the given budget to maximize your ROI. So these are some examples uh, that you can think of when you get into any analytics project. Now let's move to the next part: actionable insights from data in a systematic way. Most of you who are interested in analytics must have seen this kind of categorization. Analytics is largely of four types: descriptive analytics, where we need to figure out what happened. So assume you are working for a telecom company and the profitability is going down. So you will need to figure out what is happening. So what you can possibly do is to just check uh, how my customer base is behaving, uh, what is my revenue in the last 1 quarter, 2 quarters, and so on. Is it declining, improving? What is going on? And probably when you do the reporting, you figure out that it is because my customers are leaving. They're porting to a different telecom company. So here, from the action standpoint, first of all, you need to create the report. You need to create a lot of business reports and see what is the problem in hand. The problem at hand here is attrition of customers. If you now go one step ahead and see why did it happen, so that comes under the diagnostic analytics. Here the action for an analyst would be find the root cause. What is causing it? Probably you would see that a customer uh, is having a rate plan of 500 rupee and he's getting bill of 1000 rupee and he's not happy, or the customer care is not doing its job properly. So you need to figure out what is the root cause of this attrition. Third, the business leader would ask you, now what will happen tomorrow? What has happened, but what will happen tomorrow? Can you help me? Then you probably need to build a statistical model to come up with the predictions or forecasting that, okay, this customer has a probability of churning in next 12 months at this number. So then you will get a list of customers and the probabilities across all of them. But then the question would come, what should I do about it? I know now who's likely to churn, who's not likely to churn. What should I do about it? So the action for analyst would be recommend the business actions. Right? So you need to provide some actionable insights to the business so that they can take some treatment to that. Right? So for example, in the example I took, the rate plan is 500 rupee and there's a bill amount of 1000 rupee, then there's an overage of 500. Probably you can recommend that why don't you just upgrade the handset, or you just call up the customer and offer a different rate plan of 700 rupee that can take care of all the services that he needs, uh, because of which he's getting a bill of 1000 rupees. Now, with a better rate plan of 700 rupees, he's not going to get a bill of more than 700. In this situation, he will be happier and probably not at right. So those kind of actions you need to recommend to your business. Now, I'll also add one more point here, that if now we know what actions are to be taken across all the stages of analytics, but what is the opportunity? Opportunity for a business analyst to shine further. If you're creating a report, you have an opportunity to automate. So you can make sure that these reports should not be just on demand, they should be created through an automated system, so that this becomes a norm for the business to keep monitoring such actions. Second is when you are diagnosing, so you should also think of visualizing it and communicating it. So you can apply some BI and data visualization tools and make it even better. Rather than just giving them the root cause, you can go to your stakeholders and let them know that this is how it looks like, so that they get convinced. They also trust you more, and they understand actually the data is looking like this. Why don't we analyze it further and give me more insights around it? So it's going to help you to make your analytical solution more sophisticated. The third one, when you're building the statistical model, the opportunity is to enhance the accuracy. And you can do that by probably switching to a different technique, upgrading it to machine learning, or suggesting an ensemble of some existing model and your new model. So just see if you can improve the accuracy over time, so that the solution keeps on evolving over time. The fourth one, when you are recommending the business actions, the opportunity is to quantify the business impact and show it to business. Unless and until you show the impact, the solution will not have that much value. So the suggestion here is that apart from doing the actions that are listed below, you should also look at the opportunity area, so that you can put an icing on the cake, and the clients, stakeholders, seniors, they understand that you are adding value to the organization. Now, let's also look at some analytical framework that we can use to top up our analytical solutions, so that our throughput can be maximized. And I'll talk about very basic frameworks, at least that will help you get the context here. So when you have a model, and let's say it's a classification model, you have predicted probability of attrition for every single customer. You cannot go and retain everyone. You have to prioritize. So when you go to business, you recommend a solution, also come up with a logic of how you're going to prioritize your customers and how the treatment should be different for them than others. So prioritization is one of the key objectives that you have to keep in mind whenever you're providing a solution to your customers. The second important analytical framework is the cost and benefit analysis. So assume you have a list of things that you've identified for business to take action on. But now, since it's a plethora of things, let's say 100 items, now you cannot expect business to go with all 100 items in one go. You have to plan. And the way to do it is divide them into cost and benefit metrics. It's a 2x2 matrix of low high categories. Look at those items which are of high cost and low benefit. So they should be discarded in the first go. Anything that is costing you more than the benefit you're expecting, you should not be investing your time on that. If there is low cost, high benefit, that should be a low hanging fruit. That should be the highest priority, and you should recommend that to business. If there is a thing which is of high cost and high benefit, it should be evaluated. If it is going to help you in the long run, probably you can go with that. But if there's an item of low cost and low benefit, that should be of low priority. There will be always some temptation to go for it because of the low cost. But you also need to keep in mind the ROI. If the benefit is also low, then you should not be prioritizing it over the high cost and high benefit item. So what I mean to say here is that once you have the solution in place, once you have identified the actions to be taken, then also you can top it up by creating such kind of a framework and communicate to your clients or customers that you should not go after everything in one go. There is a way to go about it. So there is a path. First of all, go with high priority, then medium priority, and then low priority items. Okay, now if we look at the third framework, so that's generalization. So most of you must have done some term projects or some capstone projects where you must have built a model. So we typically build a model on a data set, a trained data set, and then try to validate it on test data set and out of time validations. Right. So here, let's say this is a scenario. We have a 90% accuracy on trained data set, 60% on out of sample, and 30% of out of time. And in this situation, the question comes, can I go with this model? Well, clearly there is a huge overfitting problem. When you are trying to generalize, you need to implement this solution on a new data set. The accuracy drops from 90% to just 30%. So can I go with that? Probably not. And if you look at a different scenario where we have 80%, 75%, and 70% respectively compared to a previous model, clearly my accuracy on train sample has reduced, but the gap between train and out of time has also reduced. So this is definitely a more practical model, though on train sample, the accuracy is lower than what I had before. So a good model is not always about maximizing accuracy on train sample alone. That is one another point I wanted to convey so that you keep in mind while recommending any model or solution to your clients. Now, if we summarize how to become a data analyst, first of all, you need to choose your track. And we discussed about tracks for coding. There can be separate tracks for in analytics also, like assume descriptive, diagnostic, predictive, prescriptive as separate tracks. And again, you have to choose your track wisely. And then, first of all, acquire the missing skills. So you don't need to acquire everything. You don't need to go after every single thing. Try to learn the path, how to evolve yourself from basic to intermediate to advanced level. Then pick the business problem statement, and it should be a real one, so that when you try to solve for it, you should be able to also show the benefit. Then after having the business problem statement defined, you need to acquire the domain knowledge. So it happens that you may be part of a bank, and obviously it becomes an expectation that you should know banking. You should know risk, operations, and marketing for a particular bank. But if you are working for, let's say, a consulting firm or services firm, then your problem statement may keep on changing every now and then. In that situation, you will have to keep acquiring domain knowledge as you keep shifting your projects. So this domain knowledge or the domain understanding is very, very crucial, and we should not be trivializing it, thinking that I just need to call some functions or libraries and I'll get the model done. So you need to acquire domain knowledge. This is an important step. Then you need to research about the feasible techniques. Do not go with just one technique. Always see what are the different options that you have, evaluate them, what are the pros and cons, like the way we talked about cost and benefit analysis. You have to apply those things, and then shortlist a couple of techniques to go for. On top of it, you need to apply your analytical frameworks. So once you have your solutions and models ready, the kind of frameworks we talked about, the cost benefit analysis, generalization, prioritization, automation, segmentation. So those analytical frameworks you need to put on top of your solution. And then you think of upgrading yourself, again, choosing your track, acquiring the missing skills, and so on. So that should be the path to become data analyst in my mind. And just in the interest of time, I will give you one more nugget, that if anyone asks you, are you joining analytics industry? The answer is no. Analytics is not an industry. Examples of industry are banking, retail, hospitality, and so on. Analytics is industry agnostic. It is applicable everywhere. It's all pervasive. It's a service either to yourself, to your organization, or to others who are your clients. So just keep that in mind. And with these thoughts, I'll pause here and ask if you have any questions for me.
Fabulous, Varun. Thank you so much. I think it was fabulous, and it's very encouraging, I think, for our participants to hear that, you know, even if they do not have a coding background, they can indeed opt for careers in analytics. It's very, very encouraging for them. And thank you so much for that, you know, detailed explanation on so many things. We have one question, you know, from Lovina, which is actually representative of our audience. So over to you, Lovina.
Thank you, Maya. So Varun, I meet a lot of learners who want to make a career in data analytics, but they are always confused about two things. Okay, uh, what should I choose? And I'm going to tell you exactly the question that they ask us. Okay, what should I choose? Should I choose data analytics, business intelligence, or data science? Okay, one very common question. And then this is followed by another question, which has less coding, which has more coding. And so I will pick and choose the best combination. How would you answer that question?
So I would say the starting point would be data intelligence, where you need to first of all apply basic logics, like we talked about cost and benefit analysis. If you think about it, even without any specialized knowledge or course, you can relate to it, right?
Yes.
So those things are very easy to apply, and you can do some secondary research. You can look at some research papers, acquire knowledge from there, and apply your solution on top of it.
Okay.
But if you go with data analytics, then you will need to learn a little bit more techniques, more statistical tests, and it will require some effort in terms of both statistics as well as coding.
Okay.
If you talk about data science, that is even more complex, because there you probably will need to invent a bit, right?
Okay.
So that would require more effort in terms of coding as well as applying logic.
Okay,
So the complexity level will keep on increasing, and that is why data science is a very high paying job, and probably it attracts everyone that, okay, we should just go with that. For that matter, many people confuse AI, machine learning, deep learning with calculators, right? So we also need to understand that everything is not AI. If anyone is offering you AI job, you first of all need to understand what are you trying to do, what problem are you solving, and how you're doing it.
Yeah. Great. And how would you connect this with business intelligence? Because many of our learners, when they come and ask us these questions, so they feel business intelligence is the easiest of them all, because it is not coding, it is only presentation of data. So I don't have to do coding. I just have to use the data and present it in a nice, fancy manner. Is that a myth, or is it the reality?
So business intelligence definitely is about summarizing the information, giving the visualization to it, and presenting it. However, it will require understanding of domain. At the same time, after a certain period, it will become repetitive, right? So if you want to keep evolving or keep challenging yourself, it will be better to also keep upgrading yourself in terms of roles. So you may start as a business intelligence person, but eventually I would suggest that you should try to upgrade yourself and see if you can also come up with a handmade solution rather than using some tools to present data.
Fantastic.
Fabulous. Thank you so much, Varun. There are a lot more questions, but in the interest of time, we'd love to sort of email them to you, get the answers, and then circle back, to our participants and answer those questions if that works.
Sure. That definitely works. Thank you.
Thank you so much, Varun. It was an absolute pleasure to have you here. See you again soon.
Sure. Thank you.